Hi, algebra students. Today we're going to be looking at some more absolute value functions. Starting with graphing f of x equals 2 absolute value x. So from yesterday, you should have seen that you can do this without a calculator. So our vertex is at 0, 0, and our slope is up 2 over 1. And that's in both directions to form the v of the absolute value. We connect all the dots, put arrows on both ends to show that it would continue. And in this case, we're going to make sure we label today because we're going to be graphing more than one equation on the same coordinate plane. All right, so we want to see if g of x is equal to f of x plus 4, how is the graph of f of x transformed to form g of x? So first we have to figure out what the equation of g of x is. So since it's f of x plus 4, we take f of x, which is 2 absolute value x, and add 4. So that means when we graph it, it's going to be 4 units up from the original f of x equation. So we're going to start at 0, 4, and then have the same slope. So g of x is now that purple line there. And we can say that it shifted f of x up 4 units. All right. Then from there, it says if h of x is f of x minus 3, how is the graph of f of x transformed to form h of x? So now we have to rewrite h of x. And since f of x is 2 absolute value x, this is going to be 2 absolute value x minus 3, which tells us that it's going to shift it 3 units to the right because of that minus 3. So 3 units to the right would be here with the same slope. And that would be our h of x. And we can then say that it shifted f of x 3 units right. So hopefully this seems a little familiar because we did this very similarly when we were working with quadratic functions. All right, so you're going to complete 4 through 6 on your own and then pick up where we left off. So for number 7, we're graphing f of x equals the absolute value of x minus 4. So we know that means that it's going to start at positive 4, 0. And there's just a slope of 1. So up 1 over 1 in each direction to form the v. So that looks like this. And be sure to label it f of x. And now moving on to number 8, it says if g of x is negative f of x plus 2, how is the graph of f of x transformed to get g of x? So first we rewrite our equation. G of x is negating f of x, so negative x minus 4 in absolute value, and then adding 2. So that's what it would look like. That gives me a vertex of 4, 2, and then tells me to go down 1 over 1 instead of up 1 over 1. So 4, 2 is here, and then it's going to go this way. And that is now our g of x. So this one reflected f of x over the x-axis and shifted it up 2. All right, and one more we have, if h of x is f of x plus 2 minus 5, how is the graph of f of x transformed to find h of x? So again, we have to rewrite our equation. So now we have h of x, and we go back to our original f of x, which is that x minus 4. Adding that 2 in is going to make it x minus 2, and then putting the minus 5 on the outside. So now my vertex is 2, 5 instead of 4, 2, which was in g of x. So we go right 2 and up 5. oh no, right 2 and down 5 because it's negative 5 rather, which is right here. 2, negative 5 is our vertex. Remember that when you're looking at vertex form, it's the opposite of this one, but it stays the same as this one. And our slope stays as positive 1. So we're going up 1 over 1 in both directions. And we're going to label that g of x. So we know that this shifted f of x left 2 and down 5. Remember with the right and left transformations, it's always the opposite of the sign in parentheses. All right, so I hope you're understanding this and you see how you can easily do some absolute value functions and transform them on the coordinate plane. You guys are going to try numbers 10 through 12 on your own. Be sure to check in with me so that I'm sure that you've got it right before moving on to your exit tickets.